Hi guys, I hope you're good. I hope you're well and excited for our lesson today. We are still working with exponents, but today we are looking still at exponential equations, but now with a bit of a twist because we have the same base, one power, but it should be negative of the other. So this is also a bit different from our previous lessons, but it is very important for you to know how to deal with this kind of a situation. Okay, so guys, now let's be ready for our first part of the lesson, in which we look into understanding what exponential equations are. And guys, I will remind you this: in every lesson of exponential equations I will go through the rules, I'll go through the laws of exponents, because you really need to know and you really need to understand what are we really dealing with. So exponential equations have the unknown variable in the exponent, so the power here needs to be the unknown variable. Okay, that's why they're called exponential equations, because they don't have an actual value as an exponent, but they have a variable instead. And we can write a single term with the same base on each side of the equation, and we can equate the exponent. This is our golden rule, guys. We keep this rule with us all the time. We need to use this rule all the time. The moment you have the same basis, what do? You equate the exponents. And this is one of the methods that we use actually to solve exponential equations. All right. And guys, now that we have seen the definitions of exponential equations, we need to start thinking about how to solve equations involving them. In this section, we look at solving exponential equations where we have the same base, one power, but negative of the other. So I told you earlier on that we have a bit of a twist on this lesson, because now we'll be having the same base, and the power needs to be the same because we need to actually have the same variable. So it means now we need to have the negative of the other. So now let me show you how we actually do this. But before we get into that, I want to remind you of the law that I've been talking about, that we need to always remember. And guys, I will highlight here, we need to always go back to the laws of exponents. Laws of exponents, very, very important. You may not use all 10 or 11 or 15 of them at once, but you need to know, looking at the situation, that which rule am I applying now. Okay, so you need to always be alert, guys. Please, please, please revise, go back to our previous lessons where we dealt with laws of exponents. Everything is there. Okay, so now the law of exponent that we'll be looking at today, it will be the one that says if you have the same base, if the same bases both sides, you have base b to the power of x on one side, and you have base b again, but to the power of negative x on the other side. Okay, so let me actually use a different value so that you can easily equate. So if you have negative y instead, so that simply means you have b and b there, you simply have x equal to negative y. So same base, equate the exponent. Whether the exponent is negative, whether it's positive, just equate the exponent under the condition that you have the same basis, guys. Always remember the rules. All right, now let's go to our first example and see how we can work things out. So we have 4 to the power of x plus 1 equal to 2 to the power of negative x this time around, plus 3. That is interesting. So you have a positive exponent on the other side, you have a negative exponent on the other side. And what do we do in such a situation? Now, because I wanted to give you something challenging, I made sure that your bases are not the same when you start. The bases are not the same. Who has to make them the same? It is you guys. We need to, actually both of us, so we need to try and make these exponents, these bases, the same. And going back to the laws, guys, that we've always worked with, we need to understand the moment we have 4, we can write 4 as 2 to the power of 2, but remember that it had values next to it, so it had exponent x plus 1, and you equate this to 2 because you can't simplify it any further, so you have 2 minus x plus 3. And then Now what you have to do, since you have the same basis, you simply equate the exponents. It doesn't get any difficult, guys, so I want you to go through this thing again, okay? So you can go back, try to follow everything that will be saying. If the bases are the same, you equate the exponents. So now you have, first you can start by expanding. So you have 2x, 2 to the power of 2x plus 1 equal to 2 to the power of negative x plus 3. So actually it shouldn't be plus 1, it should be plus 2 there. Sorry guys, when we expand both values. So now our bases are the same. We now equate the exponents. So you'll have 2x plus 2 equal to negative x plus 3. And there you have it. You have yourself a linear equation. How do I know it's a linear equation? The highest exponent on the variable is 1. So I have a linear equation. I need to use the normal laws of solving a linear equation. So one of the most important things that you need to do when you have a linear equation like this, guys, is that you need to group like terms together. So values with x, they can be one side. So you have 2x and we have x on the other side, so we can take the x to the other side, so that becomes positive x. And you equate these two, what remained, it was positive 3, and you need to take that positive 2 to the other side, so it becomes negative 2. And if you simplify this, you have 2x plus x, you have 3x, and you equate this, what is 3 minus 2, you will find yourself with 1. And we're solving for x, guys, so we divide both sides by 3, means the value of x, therefore x is given by 1 over 3. And as I always emphasize on the lessons, guys, it is okay to leave the value of x, y, or any equation that you've been trying to solve as a fraction. It is very, very, very acceptable unless you've been told otherwise, okay? But this is okay. So this is how you solve these exponential equations, where one was positive on one side, one is negative on the other side. So this is how we actually work with it, okay? Now I have another example for you that I would like you to do it first before you come back for the answers, okay? But if you manage to do it by now, let's try to do corrections together and see what are we finding. So you have 9 to the power of x equals to 3 minus 3 to the power of minus x plus 2. Now, as you can see, again, one exponent is positive on one side, it is negative on the other side. It's still the same power, it's x, right? But it's just that one is positive, one is negative. Now, bases, still, I gave you something to work with, they're still not the same. We need to make them the same. So this is how we do it. So if you have 9 can be written as 3 multiplied by 3. So you have 3 to the power of 2, but you have x next to it. So you simply say 3 to the power of 2x. And then you equate this to 3 to the power of negative x plus 2. Now, what do you have in such a situation? You have same bases, guys. Remember, the bases need to be the same. The bases need to be the same all the time. So once you have this case, it means you can say this is 2x equal to negative x plus 2. So now you have a problem that you need to try and solve. And you find yourself with the linear equation, you should be very happy. They are the simplest equations that you ever solve, okay? So once you find yourself with the linear equation, you have everything that you need. Now, this is what you have. So you simply say this is 2x plus x equals to 2. What did I do there? I just grouped like terms together. So I just took x onto to the left hand side, and I just remained with 2 on the right hand side, okay? And then now we can simplify one side, so you have 2x plus x. So 2x plus x is going to be 3x, and you equate these two to 2. Now solving for x, we divide by the value disturbing x, so we divide both sides by 3, and therefore x is given by 2 over 3. That's how you do it, guys. That is how you work around with these values, where you have to make sure that the bases are not are the same if they are not the same, okay? And also you simply equate the exponents, whether one was positive on one side or negative on the other side. It's okay, guys. The laws of exponents do not change, all right? They do not change. So the third one is all yours, and I want you to try it, guys. I want you to try it now. What I did here is bases are the same from the word go. Bases are the same. Exponents, you have one positive on the other side, you have one negative on the other side. Let's see how do you actually manage to do this one. So if you have tried it, or if you haven't, you can try to pause the video now and come back for corrections. And if you are done with the problem, now let's continue and see what we get. So you have the same bases. That means good news, guys. The moment you have the same basis, that is the best news you can ever get, okay? What you have to do now is simply equate the exponents. So you don't have to try to change any value there. You don't change anything because automatically your bases are the same, okay? So you will have 2, since the bases are the same, since base 2 and base 2, you have base 2 both sides, you simply say this is x minus 1 equal to negative x plus 1. What did we do there? We applied the one law of exponents that we discussed earlier on, where if the bases are the same, you equate the exponents. And in front of you right now, you have a linear equation that you simply need to follow one rule that says group like terms together and simplify. So now let's try to group our like terms together and simplify. You have x, and we take negative x to the other side. It becomes positive x, and we were left with 1, and we take the negative 1 to the other side. It becomes positive 1. So it means now you have x plus x, which becomes 2x, and you have 1 plus 1. 1 plus 1, guys. 1 plus 1, come on. It's 2, right? So you simply have 2. Now, once you find yourself in such a case where you don't have x standing alone, you need to ensure that x definitely stands alone at the end of the day. So you have to divide both sides by 2. So if you divide both sides by 2, you have x being 2 divided by 2, guys, that is 1. So that is how you solve this exponential equation, where you have the same basis and you one power but negative of the other. So that is how this is how we need to work with these equations, guys. So guys, thank you for joining me on this lesson today, and I will definitely see you on the next one.